So this video is part B to graphing a parabola in vertex form. And specifically here, what we're going to do is we're going to try to take a parabola that we're already given on a graph and find the equation for it. Once we get that equation from the factored form, we're going to expand it out to get it in standard form. So let's do that. Here's our graph. You'll notice that we have we're told to write an example in the form y equals ax squared plus bx plus c for the parabola shown. Now, we could look at the graph and say, well, I think I know what the vertex is, but we're not given that point, so we have to do it just with the points that we're given. So what we're going to do here is we're going to take the points -3, that's the r value in this y equals a times x minus r times x minus s. And we're also noticing that s, the other 0, is 1. The other x-intercept or 0 is 1. And so if those are the two zeros, x-intercepts, roots, those are all the names for those, then we can sub them in. So let's go ahead and sub those in. That's going to give us y equals a x minus -3. Some of you would jump ahead and just write +3, but just so it's clear, I'm just putting it as minus -3. So that's y equals a times x plus 3, x minus 1. And now what we want to do is we want to sub in the other point. So we're going to sub in the other point xy as -2 and 6. And so that gives me y is 6, x is -2, and we're going to sub all these in, and we get the following, and we need to simplify that. Now notice the only value we don't know is a. Just like when we were solving something in vertex form from the graph, we're solving for a again here. So nothing really new to us at this point, but still something that's just coming at it from a bit of a different angle. So 6 equals a times 1, -2 plus 3, times -3. And a times -3 is -3a. If we divide both sides by -3, we would say that a is equal to -2. Okay, great. A is equal to -2, so what does that mean? Well, that means we go back to this form right here, and we sub a equals -2 into that. So we're going to get y equals -2, x plus 3, x minus 1. That is the equation, but that's not the final form it's asked for. It says write it in the form y equals ax squared plus bx plus c. And this is what's confusing to a lot of people. They think they have to start with that, but we totally didn't start with that. We started with the factored form. Now we're going to put it in standard form. And so to put that in standard form, we just go ahead and we FOIL that out. First, outside, inside, last. So -2, we're going to keep out in front. X times x is x squared. Outside is x times -1, which is -1x. Inside is 3 times x, which is positive 3x. And last is positive 3 times -1, which is -3. Now we go ahead and combine those inside terms. We get -2 times x squared plus 2x minus 3. And then we go ahead and we take the -2 and multiply it by everything that's in the brackets. So this finally gives us -2x squared minus 4x. If I can get my pen working properly there. Plus 6. And that is the equation in the form that it asked us for. Now you'll notice something here. This y-intercept of 6 is right there on the graph, as we would expect. And we also know the vertex, but again, we weren't given those points. And oftentimes you'll be given a picture that doesn't have a clear a value. Here you should be able to see that, oh, I'm going over 1 down 2. So some of you looked at that right away and you said, well, I know that's going to be vertically stretched by a factor of 2 and it opens down, so a is -2. But we want to do this in a way that's going to work every time. And so this is the algebraic way to show that and how that works. You should also read example 3 on page 287 if you're in the academic text. Notice the difference of squares in that example. So have a look at that. I hope that's helpful. Email, get in touch if you have any questions. Thanks.